Hello, my name is Jason Zhang, and this is Charged Tapes Revisited, Lab 2 for Physics 2212. Here's the table of contents, and let's get started with the purpose. The purpose of this lab is to produce a computational model of two charged tapes exerting electric force on each other that is more accurate than approximating each tape as a point charge, which is what we did in Lab 1. To accomplish this, we will distribute 10 point charges evenly along a line to represent each piece of tape. And using this model, we will get a better approximation for the electric force and the electric charge on each piece of tape. Here are the fundamental physics principles we'll be using. Starting off, we have Coulomb's law, which gives us the electric force between two charges. Also in lab 1, we saw the charge of an electron, and that was used to calculate the number of electrons on a piece of tape, but that's not so important for this lab. Of course, we also have Newton's second law, F equals ma, and that allows us to derive the gravitational force equation, which is F equals mg on Earth. Also important for this lab is the superposition principle, which tells us that the electric field at any point in space is equal to the sum of the electric fields not at that point. Here are the preview of the main results, but first let's talk about Lab 1. In Lab 1, we approximated each piece of tape to be a point charge, which simplified the calculations. And we found that the magnitude of the electric force was 0.00196 newtons, and the magnitude of the electric charge was 2.8 times 10 to the negative 8th coulombs. Now in Lab 2, we are making things a bit more complicated. We will represent each piece of tape to be 10 point charges, as we see here. And we found that the magnitude of the electric charge was 4.35 times 10 to the negative 8th coulombs approximately, and which is roughly equal to the magnitude of the electric force, which is equal to the magnitude of the magnitude of the gravitational force, as we see here in the bottom of our VPython simulation. And the electric charge we found in Lab 2 is about 55% greater than what we found in Lab 1. So let's see why. But first, here are the steps for our experiment. Let's get to the assumptions. So we will assume that each piece of tape has its charges distributed evenly. Specifically, it will be 10 point charges distributed evenly across a line. We will also assume that the experiment takes place in a vacuum and that no charges were lost or gained throughout the experiment. We also assume that the two pieces of tape were identical and symmetrical. Now here's the computational model, so let's talk about some of the important parts. So in lab 1, we found that the separation distance between the two pieces of tapes were 6 centimeters or 0.06 meters, as seen here. And here we're saying n equals 10 just to say that each piece of tape will be made of 10 point charges. And that number is used here when we define the method for creating the line charges. So we could create the tape with any number of line charges, but here we arbitrarily chose 10 point charges. Here's a method defining the electric field formula, which we use later on down here actually. So this is a loop that allows us to calculate the electric field at each point charge using the superposition principle. And all of that gives us this neat graph. And we see that we used the guess and check method to calculate the net force so that it's roughly equal to the gravitational force. We saw that we needed roughly electric charge of 2.8 times 10 to the negative 8th times 1.555 coulombs. And these are kind of just the initial conditions for the experiment. Now, here are some potential errors. So in the lab, there could have been air resistance from wind or even humidity could have affected the separation distance that was 6 centimeters. Charges would have been lost whenever we handled pieces of tape. And also, a piece of tape has much more than just 10 point charges. So the more point charges we use to model this piece of tape, the more accurate it would have been. But this is still much more accurate than just considering each piece of tape to be 1 point charge. And of course, each piece of tape would not have been perfectly identical to each other. One might have been a bit longer, with a bit more unevenly distributed charges. And also, of course, there's human error in any experiment. Now let's get to the what if question. What if we model each piece of tape as a single point charge, like in the previous lab? Well, we saw that the electric charge would have been 2.8 times 10 to the negative 8 coulombs, which is less than what we found. And in lab 2, we found a much more accurate estimate, which is 55% greater than what we found in lab 1. And why do these estimates differ? Well, it's because a piece of tape is not a point charge. So the more point charges we use to model our tape, the more accurate our estimate would be. So here we use 10 pieces of 10 point charges, which is pretty good, but also an actual piece of tape is much more. Thank you.